All right, here's our last video. I'm going to finish out this review. I'm going to work through about half of these problems about solving quadratics. So we did this a lot in quarter 2, and here we go. We're going to do all of the methods, and again, your just goal is to be able to pick and use the methods effectively, whichever ones work best for you. Okay, so the first section says solve by factoring, so just kind of practicing that, working through those steps. So the first thing we always do when we solve by factoring is we make sure that it's set equal to 0. So number 9 is set equal to 0, so in that case we look for a greatest common factor. Nothing divides out of k squared and negative 12k and 35, so we're just going to backwards FOIL. So when we break this down, right, we know that this will be k and k. We're looking for factors of 35 that combine or add to give us a negative 12. And in this case, that would be 7 and 5. And we know they need the same sign, so negative 7, negative 5. So just like our last review, except this time you are going to solve. So what would make the first piece equal to 0? Well, that would be k is equal to a positive 7. And then the second piece would be equal to a positive 5. So those two values right there would be our solutions. Okay. Number 11 and 12, this one says solve using square roots. So remember, this was another method we talked about. Notice up here, right, in number 9, we have a couple terms with k's or variables. So we've got this term right here that has a k squared, and this term has a k, making it impossible to solve just by square rooting both sides. 11, however, and 12, both of these only have one term with the x variable in it, or the n variable. So we can actually just get this guy by himself and then square root. So we're going to go ahead and isolate the n variable. So we're going to add 3 to both sides. That leaves me with 4n squared is equal to 352 when I add 349 and 3. We then divide by 4. N squared would be equal to 88. Okay, and then again, to get rid of the squared, we just square root both sides. And don't forget your plus or minus sign. We're going to have square root is 88. And then we would just simplify this, so that would be like 8 times 11, 4 and 2. And we're just breaking this all the way down. It looks like we'll have a group of 2's there, so the 2 gets to come out front. Now remember, it doesn't go out front of the plus or minus, it goes out front of the radical, so it's still part of that term. And then inside we've got 2 times 11, so we put back the 22. Okay, solving with square roots. Again, on number 12, we're solving this one, so identifying the x-intercepts, so those occur when y is 0. And then it's essentially working the same way, we just have a bigger piece that we're going to square root when we get that isolated. So we're going to start by adding 4 to both sides. Right, that leaves me with a positive 4 on the left side, and then I've got negative 2 parenthesis x minus 4 squared. We then need to get rid of that negative 2. So if it's multiplying, we're going to divide both sides by negative 2. That leaves me with a negative 2 on the left side. That goes away on the right side, and we have x minus 4 squared. Again, if we're undoing everything, then we need to square root both sides, right? Square rooting will get rid of that, so we square root on both sides. On this left side, the negative is going to come out as an I, so I'm going to write this as plus or minus I square root of 2. And on the right side, we just are left with x minus 4. And then we just finish solving for x. So there's a negative 4 over here, so let's add it over here to the left side. That leaves me with 4 plus or minus I square root of 2. And then we have x left on the right side. So it's solved there. Again, just isolating the variable piece so that you can square root and use that as a tool to solve. Alright, those were the first 2 things we practiced in solving quadratics this year. Then we learned about the quadratic formula. Quadratic formula, remember, that's the Pop Goes the Weasel song. And we use it when it's in the form ax squared plus bx plus c, right? Standard form. And again, notice it's equal to 0, so we always want to make sure that's our first step. Quadratic formula. Hope you're singing this song in your head. X is equal to, right? We did the opposite of b, so always opposite of b plus or minus the square root b squared minus 4ac all over 2a. There's our quadratic formula. So we're going to use that a little bit down here. This says solve each equation using the method of your choice. You can use the quadratic formula, right? That always works. Or factoring, which is the fastest method if it's factorable. Or square roots like we did above. Or completing the square. So we'll do kind of one of each as we move down. I'm going to do 14, 16, and 18. So again, the first thing we always do is set it equal to 0. Well, number 14 is already equal to 0, so we're good there. The second thing is we look to see if it's factorable. So there's nothing that divides out of everything. No greatest common factor. So I look to see if there's something that multiplies to 9 that will add to 3. Well, factors of 9 would be like 9 and 1 or 3 and 3. Neither of those pairs will add to 3, so this one's not factorable. So I then look at the middle piece. That is an odd number. Now remember, when you complete the square, you take half the middle term and then square it to find that perfect number. So that's going to create fractions. So on this one, probably my best choice is the quadratic formula. So let's go ahead and use that. So I'm going to identify my A. My A in this case, right, is 1. It's that coefficient. B in this case is 3. And C is 9. Now don't get confused because this equation uses b's instead of x's for your x value. But so when we set this up, we're going to do the opposite of b, right, using that formula. So negative 3 plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is 9, all over 2a. And then we just simplify. So again, remember that negative 3 stays out front, and we're all over 2 times 1. So we start by simplifying the radical. Inside, we've got 3 squared, which is 9, minus 4 times 1 times 9, which is 36, negative 36. So 9 minus 36 is a negative 27. Okay. And then we're just simplifying from there. So remember, this negative is going to come out front and it's going to be an I. And then we can break down this 27. So we're going to have like 9 and 3 and 3 and 3. Gives us a group of 3s. So this group, right, is going to get to come out with that I. Now remember, it doesn't come clear out to the front. That's a different term. So what we're going to have is negative 3 in the front there, still leading the way, plus or minus that 3 that got to sneak out front with the I. And then we have the square root of, and it looks like there's a 3 left inside, so a lot of 3's there, all over 2. And our last step with the quadratic formula was just to see if there was something common that divides out of those 3 terms, coefficients. And we look at those and nothing divides out of all of those, so we are actually done right there. That is our solution to number 14. All right, jumping down to 16. So again, we're going to follow all these same steps. So the first thing is to set it equal to 0. So we're going to go ahead and we're going to subtract the 3 to the left side so that it's equal to 0. Okay, so we've got b squared plus 20b plus, looks like 58. Okay, now as we're simplifying this one, if we want to factor, we could look to see if it's factorable. So first of all, does anything divide out of all these terms? It doesn't look like it because there's no coefficient out front here. So then we look to see if it's factorable. 58, the only thing that multiplies to 58 is 1 times 58 and 2 times 29. Definitely doesn't add to 20. So on this case, it doesn't look like it's factorable. We look at the middle term. Notice that's an even number. So completing the square might work really well on this one. So let's try completing the square. So we're going to do b squared plus 20b, and then we leave that spot, right, to finish out completing the square. And then we're going to move that 58 to the right side. So we're going to have negative 58 on the right side. To find that perfect value, we take half the middle term and square it. So half of 20 is 10. 10 squared is 100. And if we add 100 to the left side of the equation, we need to keep it balanced by adding 100 to the right side of the equation. And then we factor the left side. So we've practiced this quite a bit, doing our circle equations and ellipses. Oh, not two. B plus 10, right, squared. And on the right side, that would leave us with 42 when we combine that. Then we're undoing the squared, so we're going to square root both sides. So in this case, we've got b plus 10 and plus or minus the square root of 42. Now if we could, we'd break down the square root of 42. That would give us those 6 and 7, and 6 is 2 and 3, so there's no groups there. So our last step on this one is just to then subtract the 10 over to the right side. So we've got b is equal to negative 10 leading out front plus or minus the square root of 42. Okay, it's a little messy. Again, that one I just chose to complete the square. You could use the quadratic formula on that one. Just simplify down. Again, this one we did the quadratic formula. This 16 we completed the square. And then looking at 18, let's kind of see what's best on this one. So we start by setting it equal to 0. Again, so we're going to move this 80n to the left side. And it's going to go in the middle so that it's in standard form. Plus 168 equals 0. And again, we start by looking for a greatest common factor. Notice that on all of these, they are divisible by 8. So we can divide by 8, divide by 8. And when we do that, right, that's going to simplify numbers for us a little bit. Now, when you do that, the reason we can just divide the 8 completely away is that we divided both sides of the equation by 8. So we've covered all of our bases in dividing that out. Does it make for like steeper parabola if we graphed it because the 8 was there? Yes, but those x-intercepts are the same, so solving, we're going to have those same solutions. All right, then we're going to see if it's factorable. If we look at 21, so things that multiply to 21 that add or combine to give us 10. So 1 and 21 definitely doesn't work, but if we look at 3 and 7, those are both negative, that would give us that negative 10. So we could go ahead and write this as n minus 3 and n minus 7. Okay, and then again we're solving, so n is either a positive 3 from this piece or n is a positive 7. Okay, now again I factored because I could tell that it was factorable. That was the fastest way to solve for me, but you could do complete the square. Notice that's an even number in the middle, right? So that wouldn't be too hard to complete the square. All in all, no matter what you apply, you need to simplify all the way down to the end. So again, I could use the quadratic formula on this one. It would just take a lot of simplification to get me to this point. So any of those methods are usable. We just need to make sure that we simplify it all the way down to the end. Okay, great job. I know those are a lot of different methods, reviewing all of that. Just make sure that we're pretty comfortable with solving all the way down.